Hello everyone. This video is about our project Luminary. Physics is a subject which deals with atoms in the microcosmos to the galaxies that occupy the macrocosmos. After almost 6 years of dealing with physics, we have found out that there are two types of people in this world: those who understand physics and those who don't. In these 6 years, we have also realized that the majority belongs to the latter category. The dislike usually begins around kinematics, and by the time of oscillation and waves, it turns into a deep-rooted hatred. The fear surrounding the subject just makes it another course you have to just pass. In 2016, the Department of Physics and Statistics of Walaita Sodo University, Ethiopia, conducted a study to analyze the interest of grade 10 students towards physics. Around 71.4% of students disliked or hated physics, and these were the major reasons for dislike towards the subject. 36.7% of the students said that the teacher's approach was not good enough. The teachers told the students to muck up laws and formulas, and the students were forced to read lines from a textbook and copy derivations down from the board as the teacher wrote them down. 22.4% of students said the subject was too difficult to understand and the concepts were not getting clear. 18.4% of the students said that there was no practical session held, which confused them further with the concepts. 14.3% of the students said that the topics were too difficult, and 8.2% said that they did not find any particular significance in the subject. Looking at these reasons, we can say that this dislike for the subject is mostly triggered by the lack of understanding and inability to solve questions. These are some of the similar and existing solutions that we will be treating as a benchmark for our project Luminary. Seeing Theory is a website which helps in visualization of the difficult mathematical concepts of probability and statistics through interactive graphs and notes for a better understanding. Khan Academy contains several topics ranging from elementary school to university level. The topics are explained through videos and notes, and the users can keep track of their progress and take quizzes to test their knowledge.
We have already discussed the reasons why students dislike physics very briefly. Using the data from the survey we discussed, it is easy to identify why students are disinterested in physics. Students feel that they are being forced to mug up formulae and derivation just for the sake of scoring up marks. They feel this way because they don't understand the concepts and hence feel the formulae and the derivations need to be mugged up. If a student were to understand why a particular formula is the way it is, they would have no difficulty in recalling it when needed. This can be due to a few reasons. The students may feel that the teaching methods being used are inefficient. To properly understand a highly conceptual subject like physics, it is necessary to imagine 3D scenarios. And drawing 3D scenarios on a 2D surface like a whiteboard or a paper can be tough and can further confuse a student. Many students also feel that there are not enough practical sessions held which complement the theory they have been taught in the classrooms. Many institutions with limited budgets have limitations on the type and the number of lab apparatus they can afford, and thus every student can't get the desired amount of exposure to practical experiments. This is an understandable problem since practical sessions help in clearing up concepts. As students who have faced similar problems in the past, we think we can present something that solves many of these problems the students face. Our project Luminary. In our project Luminary, we propose a lightweight interactive website that allows students to understand various concepts of physics using interactive graphs, charts, and videos. Watching visualizations and especially interacting with them will allow students to understand concept better and thus improve their overall interest in the subject and also allow them to excel at it. Let me now discuss the tech that must be utilized to develop this project. As we plan to make a website, HTML and CSS will be two key components used. Using HTML, we will define the basic structure of the web pages and then we will use CSS to further style these web pages and make them look attractive. To allow for interactive visualizations, we intend to use JavaScript to make the front end of the website more dynamic. Before the coding begins, Adobe XD will be used to plan the layout of the web pages so that once the coding begins, there are no doubts about the design or the UI of the website. Let us now discuss the software requirements needed from the user side to access a website. The user must be using a device that supports web browsers. Further, the web browser being used must support the latest version of HTML that is currently HTML5. The user may also make use of hardware acceleration. However, this is not a mandatory requirement but just a recommendation, since hardware acceleration gives an edge to the user by enhancing the visualizing experience. Let us now identify the stakeholders in this project. The most important stakeholders are the team members Anwesh, Dev, Pushkar, and Shobhitaa who are working on this project. The next stakeholder is our mentor for this project, Dr. Anurag Goswami, who offers his advice and suggestions. Next will be the educators who will contribute to the content of the website. The students will also be stakeholders since the website is created and targeted for them. The final stakeholders will be the investors who provide us with additional resources if we require any.
These are the different types of users who will be using our website. Students are end users who will use the website to learn and clarify concepts and topics of physics through the provided interactive content. Instructors are end users who will use the contents of the website in their courses and suggest topics and examples to add. Developers are either team members or users who are tasked with creating interactive content for the website based on the suggestions of instructors and students. Administrators are team members who are creating and managing the website. For our first sprint, we decided to take up two user stories covering the features of registration of accounts of separate subscriptions for different types of users. We managed to complete both of those features in time. For our second sprint, we took up two user stories covering the functions of searching a topic and tracking progress of a user through the topics. We completed the feature of tracking progress of topics, but we decided to terminate the work on finding topics through a search bar since it required more work than we planned initially. We might pick it up after completing all the other required features. For our third sprint, we decided to take up the user story covering the feature of interaction with graphs for better understanding. And for the fourth sprint, we chose to work on simulations for experiments, and we completed both of them well enough on time. This is our use case diagram. We have four different types of users: admin, developer, student, and instructor. The admin can manage accounts and manage the website. The developer and the instructor can create the content, which is later on approved by the admin. A developer, student, and instructor can view the topics and interact with the content, or send suggestions if required. All three of them can also register for an account and get a subscription if they want to. An instructor can make groups of students and add them or remove them as required. An instructor can create the quizzes, attempt it themselves, and the students can attempt it as well. This is our activity diagram. A user is first required to attempt to log in. If the login is not successful, then they can attempt to log in again. If the login is successful, then we check the subscription of the user. If the user happens to be a student, then the user can attempt the quizzes provided on the website, or they can view the topics and interact with them. If the user is not a student, that is, the user is either an instructor or a developer, then they can view topics, create groups, create quizzes, or create content. To create a group, a user can add other users, after which an acknowledgement would be sent to the members of the group. To create a content, the content has to be approved by the admins. If it is not approved, it is not uploaded on the website. If it is approved, then it is added to the already provided list of topics. After each session, the user is required to log out. This is a class diagram. For the time being, we have decided to work with 5 classes: user, admin, topics, quiz, and groups. Several users can be part of several groups, and several topics can be included in many quizzes. This is a sequence diagram. This shows the relationship between users, classes, and functions, and how they interact with the database which has been created using Firebase. This is our data architecture. For the time being, we have created 4 tables for user, groups, topics, and quizzes. The relationship here is that many users can be part of many groups, and many quizzes can contain many topics. This is the end of our presentation, and we would love to hear any questions or suggestions. Thanks a lot for watching.